All right. So we're going to talk pH, pOH, and that will be our heading here. pH and pOH. You've heard of pH, maybe not pOH. We're going to make a little chart here to kind of compare the two. First of all, we're going to have, and so this is down further, and then we're going to make teeter-totters. This is the teeter-totter. This is the fulcrum. And if this is the teeter-totter and there's more of something, H3O plus, remember whenever you have an acid, H3O plus is formed. So if there's more H3O plus than OH minus, and if it's in brackets like this, that indicates its concentration. That's what the brackets mean. So the molarity. So if there's a higher concentration of H3O plus than OH minus, that would be an acid. What's true about the pH then? Lower than 7. Somewhere lower. If this teeter-totter is totally out of whack and there's way more H3O plus, well then you might have a pH of 0. If it's just slightly more, you might have a pH of 6.3, something like that. Less than 7. But if you have a pH of less than 7, that means that you have more H3O plus, for sure, in that solution. But there is some of each still. Every solution has some of each. It might be just a very, very, very little bit, but there's every solution will have some of each. The next possibility is what if on this teeter-totter, which I've now moved down and to the right, which should just be to the right, but oh well. I have OH and H3O plus being exactly, for sure, totally the same. Not easy to do, but if that were the case, what type of solution? Neutral it is. And my pH is then? 7. Yep. If my other possibility then is in place, my teeter-totter has more OH. Again, I'm not comparing how much more at this point. It just has more. If there's more OH than H3O plus, that means I have a basic solution, and the pH is more than 7. How much more? Well, it depends on how much more OH there is. It could be a lot more OH, and you have a pH of 13. It could be just a slightly more OH, and you have a pH like that water that we just tested, a pH of 8. pOH is something that you probably have not heard about before. You've heard about pH back in 9th grade, maybe in middle school. Same thing goes for neutral. Neutral still equals 7, but then the numbers for the pOH for the acid are the opposite. More than 7 makes it an acid, and less than 7 makes pOH a base. If you have a pOH of less than 7, it's a base. Thank you. Questions so far? So this is just looking at pH and pOH, what makes something acidic and basic. It's all about these two ions. Remember from yesterday, if I have something like hydrochloric acid and I put it in water, the hydrochloric acid totally breaks apart into hydrogen and chlorine, but those hydrogens right away jump on the water to make hydronium and chloride. So these H3O pluses are what matter for pH. If we have more H3O plus, the pH goes down further. If we have more OH, the pH goes up further. It becomes more basic. Let's talk about how this works a little bit because it's all based on logs. So let's talk about pH, and I'm just going to go from 1 to 14 real quick. And I've already kind of told you how these work, but let's just do a quick little review. If I have something that has a pH of 2, that is 10 times more acidic or more H3O plus than pH equals what? 1 or 3? 10 times more acidic than what? Then pH equals 3. Because as we head in this direction, that is more acidic. As we head in this direction, this is more basic. And each jump in pH in either direction is 10 times more of those things. So what I mean by that is if I have something that's a pH of 9, that's 10 times more basic. Towards the 14 is 10 times more basic, so 10 times more OH than pH equals 8, because we're heading towards the 14. So there's 10 times more OH in something that has a pH of 9. So every jump going towards 14 is 10 times more OH. Every jump going towards 0 is 10 times more H0 plus, or hydronium ions. What about, let's just make up another one, 4. That's 100 times more H3O plus. Come on. Then, again, that's concentration. Then pH equals 6 is correct. Yep. Because every jump towards 0 is 10 times more than the one before it. Let's just be, this is just so fun. What is the answer? How much more acidic or more H0 plus than pH equals 7? Each jump is a power of 10. So how many zeros we need? 1, 2, 3, 4, 5, 6, 7 jumps, 7 zeros, right? So if I have some of the pH of 0, it is 10 million times more acidic. 10 million times more acidic than something with a pH of 7. Every jump is a power of 10. So there's a reason why we use the pH scale. It makes it a little bit easier to work with these huge variations of numbers, rather than talking about 10 million times and all that when we were talking about just to figure out how this works. But it's a lot easier to work with these big variations of concentration. If we want to have even more fun and talk about pH of 14, how much more OH than pH equals 0? Oh yeah. Now we have 14 zeros, right? Yeah. Oops, I don't think it's 100. It's 100. That's trillion, right? 100 trillion times more hydroxide than a pH of 0, because it's 14 jumps, power of 10. So every step is 10 times. You make 3 jumps, it'd be 1,000 times. 4 jumps, 10,000 times. Go ahead, Jordan. Good question. Does it make a bigger difference to go from 5 to 4 or from 0 to 1? No. Every jump is 10 times, so it's not any harder to make the jump from any spot to any other spot. All right, let's talk equations. How to calculate this stuff. We're going to have 4 equations that we'll refer to. Equation number 1, pH plus pOH. If I have a neutral solution, what's the pH? 7. If I have a neutral solution, what's the pOH? 7. They add up to 14. And that is always the case, not just if it's neutral. So if I have pH of 2, the pOH will be 12. If I have pH of 0, the pOH will be 14. They always add up to 14. All right, second equation. The 2 concentrations multiplied by each other. So if I take the hydronium times the hydroxide concentrations, they will always equal 1 times 10 to the negative 14th. And that's really the reason why the scale is from 0 to 14.